All right, welcome everyone. Today we're diving into something that sounds, well, completely backwards. It's one of the most fascinating and honestly counterintuitive ideas in all of medicine, the reperfusion injury paradox.
Think about this quote for a second. Restoring blood flow worsens tissue damage. What? That sounds totally wrong, doesn't it? The very thing that's supposed to save a patient can, in this kind of cruel twist, actually make things worse.
So that's the big question, right? How on earth can a life-saving treatment cause more harm? It's a medical mystery that doctors are grappling with every single day, and that's exactly what we're going to solve together in this explainer.
Okay, so our first section is called The Treatment That Hurts. Now, it's so important to get this straight right away. This isn't about a doctor making a mistake or a procedure failing. No, what we're talking about is a really complex and, frankly, dangerous biological reaction. Let's start unraveling this thing.
To really get a grip on this paradox, we can't just jump to the treatment. We have to go back to the moment before it even begins. This is where the trap is set. It's what's happening inside the body the moment blood flow stops, and it's how the cells are secretly being primed for a disaster.
So what is this initial state called? It's ischemia. And simply put, that's just the medical term for when blood flow gets cut off. No blood means no oxygen. And you know what happens without oxygen? The cell's power plants, their little mitochondria, they just shut down. It's an instant, full-blown energy crisis inside every single cell that's affected.
And from there, it's like a chain reaction, a cascade of dominoes falling. With no energy, no ATP, the cell's pumps just fail. The cell gets desperate and switches to this backup fuel, but that just creates a nasty acid buildup. And then the cell's whole electrical balance goes haywire, which forces these little calcium channels to pop open. It's just total system failure.
But here's the thing, and this is absolutely crucial. At this point, the cells are definitely injured, but they're still salvageable. They are right on the brink, but they haven't died. Not yet. The trap has been set, but the trigger, it hasn't been pulled.
And this is the moment that trigger gets pulled. Welcome to the lethal rescue. This is when doctors do what they're supposed to do. They restore that blood flow. And that act of salvation, well, that's what paradoxically unleashes the killing blow.
So what's actually going on here? See, when the blood comes rushing back, that's reperfusion. It doesn't just bring life-giving oxygen. Oh no. It brings a devastating three-pronged attack that slams into those already weakened cells all at once.
Okay, culprit number one, something called reactive oxygen species, or ROS for short. And this part is just mind-blowing. When all that oxygen rushes back into those damaged mitochondria, it doesn't get used for energy like it's supposed to. Instead, it gets twisted and converted into these super toxic molecules, free radicals. Think of them like microscopic grenades just tearing the cell apart from the inside. The oxygen literally comes back as a toxin.
All right, on to culprit number two, calcium overload. So you remember those little calcium channels that got forced open during ischemia? Well, when the blood flow returns, it's like opening the floodgates. A massive wave of calcium just pours into the cell. And this overload, it activates these destructive enzymes that basically start digesting the cell's own machinery. It's a cellular flood that causes the cell to self-destruct.
And last but not least, culprit number three is the body's own immune system. You see, when all these alarm bells of injury are ringing, inflammatory cells come rushing to the scene. But instead of helping, they just add to the chaos. They release more toxic stuff and even start to physically block the smallest blood vessels. They're preventing blood from reaching the very tissue they're supposed to be saving.
Okay, so we've seen the absolute chaos happening at the microscopic level. Now let's zoom out and see what all this means for the patient. This is the clinical fallout, how the cellular disaster actually plays out for a person and their doctor. And this right here just perfectly sums up the whole paradox. What you'd expect is simple, right? Restore oxygen, the tissue heals. But the reality, as we now know, is that restoring oxygen can cause this massive oxidative injury. You think you're reopening an artery to save tissue, but the reperfusion itself can end up killing the most vulnerable cells. Let's put this into a real-world scenario. Imagine a heart attack patient. A doctor goes in, successfully opens their blocked artery. An amazing, life-saving procedure. But then, afterward, the damage to the heart muscle can actually get worse. That, right there, is the reperfusion injury paradox playing out in real time, inside a patient's heart. And for the patient, the consequences are really serious. The area of dead tissue, the infarct size, can end up being bigger.
the patient's recovery is worse. They can develop these dangerous heart rhythms, arrhythmias. And sometimes you even get this thing called the no reflow phenomenon, where the blood just can't get through those tiny clogged up vessels. This is a huge challenge for doctors.
So, the big question is, what are we doing about all this? And that brings us to our final section, taming the paradox. How is medicine actually fighting back against this fundamental and, frankly, frustrating problem?
Well, it turns out the goal is to reperfuse gently. We can't just blast the tissue with oxygenated blood. So one strategy is something called ischemic preconditioning. It's kind of like giving the cells a little workout to toughen them up beforehand. Another is post-conditioning, where you restore blood flow on and off in short bursts to ease the shock. And of course, scientists are working hard on drugs to block those key destructive pathways.
But let's be real, there's no magic bullet for this. Not yet anyway.
No single therapy can fully eliminate reperfusion injury. This is still one of the most active and important frontiers in cardiovascular research today.
So, let's wrap this all up and look at the full paradox loop one more time. Step 1. Ischemia primes the cell, gets it ready for destruction. 2. Reperfusion comes in and floods it with oxygen and calcium. 3. This triggers this critical death pore. It's called the MPTP, to open up in the mitochondria, which basically seals the cell's fate. And 4. Cell death actually speeds up. The cure becomes part of the problem.
And that leaves us with this one powerful, really essential takeaway. Ischemia injures slowly. Reperfusion kills suddenly. Understanding this paradox is absolutely key to developing treatments that don't just open arteries, but actually save the tissue on the other side. So the big question remains, what's going to be the breakthrough that finally tames this lethal rescue?